In this video, we're going to cover EMC, or electromagnetic compliance. Now, electromagnetic compliance is a challenging issue because it usually comes up later in your design. As a matter of fact, it comes up when your design has been now shipped to a third-party lab and the lab is performing specific testing to those levels. Now, there are two types of EMC compliance to cover. One is called EMI, or electromagnetic interference. Now, EMI is when the device that you're testing is actually radiating or conducting unwanted electrical noise that can affect another piece of equipment. The other part would be EMC susceptibility, where the system that you have is being affected by some unwanted electrical noise that's coming from another device. In this video specifically, we're going to cover EMI best practices, and that has to do with the EMI, or electromagnetic interference, that is being radiated or conducted from a power supply and other parts of your electronic system. Now, here at TRC, we do get questions from time to time about the power supply EMI compliance. And what's important to note is that although we have power supply EMI data, that when you put the power supply into the system, there could be other factors that can affect the overall system performance when in regard to EMI. So before we get started on the best practices, let's talk about the standards and the actual standard that's mostly used. So today what we'll focus on is the standard called the EN 55032. Now, this is a European norm standard that's been adopted globally, and what this standard actually covers is the electromagnetic levels based on frequency. Now, there are two classes that are covered in this standard. There's a Class A and a Class B, where we would see Class B is more stringent. And in addition to that, there are two types of noise. There's the conducted noise, which is conducted back outside the AC input, and once that noise is actually going outside into the AC input again, it could actually affect other equipment that's tied or connected to that same AC point. The second piece of electromagnetic noise would be the radiated noise. This would be at different frequency levels and actual noise levels, and they usually would cover at higher frequencies because radiated noise is actually radiating at higher frequencies. These are the two types of noise considerations that we're going to make as we cover the best practices. All right, so let's go through some of the best practices. The first is making sure that your wiring configurations are very neat and separated. And what I mean by that is, if you notice that in this power supply arrangement here, the wiring is twisted pair. And what we mean by twisted pair is actually having the positive and negative wires twisted in this configuration. And what this does is it puts more parasitic capacitance along the length of the wire. And that parasitic capacitance can reduce some of this unwanted noise at various frequencies. The other thing to make sure we do is we separate the AC inputs from the DC outputs. Now, this is important because some of the noise and ripple that comes from the DC output side could cross-contaminate with the AC input, specifically at higher frequencies. And what we want to ensure is that the noise that's being radiated out of these wires do not go back to the AC line, and then of course that radiated becomes conducted again and it goes out to the AC input. Then there are other considerations, such as putting ferrite beads or ferrite cores along the output. And what these ferrite beads will do is reduce the noise at those specific frequencies. And lastly, even though the power supply may meet specific EN 55032 standards, it may be necessary to select additional filters on the AC input side of the overall system. You see that not only is the power supply emitting noise, but you also need to consider other devices within your system that the power supply is powering. For example, a computer which has a high frequency microprocessor could be a source of radiated or conducted noise. And this electrical noise can get into the power supply and then can bleed out to the system. Another device that you should also look for is any type of display. Any display may also emit additional noise that may not have anything to do with the power supply. So if you're having any type of EMI noise issues, be sure to contact our office by giving us a scan of the actual areas where you may be out of spec. We may be able to look at these areas and offer you the best system solutions for your power supply and overall system.